Welcome to 11.1, the halogens. If you need to look at your textbook for help, it's pages 166 to 167. So our lesson objectives are to describe the trends in atomic radii, electronegativity and boiling points for the halogens, and then to explain these same trends. So the first and most important question is, where are the halogens? And we should know this from GCSE, that the halogens are in group 7. So if you look at your periodic table, on the right hand side you've got the noble gases on the far right hand column, and then the halogens are just before that, so they're the second most right column. So the basics about halogens are, first of all, they're on the right hand side of the periodic table, so you should know that that means that they're non-metals. They're in group 7, as we've already said. You do need to be aware that fluorine's properties are sometimes anomalous. So that's because in the F2 molecule, you've got quite a weak FF bond, so it's weaker than you'd expect. And the reason it's weaker than you expect is that because they're very small atoms, the repulsion between the electrons is quite significant, so it means that FF bond is weaker than you would expect. You also need to know about the appearance of each of the halogens, and this gets darker as you go down the group. So fluorine at the top is quite a pale yellow gas, then chlorine is a pale green gas, then bromine is a red-brown liquid, and iodine is a black solid. You should be familiar with these from GCSEs, because you should have seen, if you haven't seen the elements themselves, you should have seen pictures of them. So the first trend we need to be aware of is the trend in atomic radii, and hopefully this is quite straightforward. So the trend is that the atom gets larger as you go down the group, and the explanation is that as you go down the group, each subsequent atom has got one extra shell of electrons, which means the outer electrons can be further away from the nucleus, which of course means that the atomic radii is going to be bigger. So our second trend is electronegativity. And before we talk about the trend, it's important to know what the definition is, which you should have met before. So the definition of electronegativity is the ability of an atom to attract electrons or electron density within a covalent bond. And the trend for the halogens is that the electronegativity decreases as you go down the group. And we can explain this using terms that we used when we looked at the first ionization energy trends. So the explanation is that as you go down the group, each subsequent atom is larger than the last. And this means the electron that's been attracted in the covalent bond is then further away from the nucleus. So the attraction is going to be weaker. The second point is that each subsequent atom's got one extra shell of electrons, and because of that, it means there's going to be extra shielding from the nucleus. So that electron in the covalent bond that the nucleus is trying to attract is going to have a weaker attraction because it's going to be shielded by these extra shells of electrons. Now these two factors, just as when we talked about ionization energy, outweigh the increasing nuclear charge. Because if it was just the nuclear charge, you would expect the electronegativity to increase as you go down the group because there's more protons. But that is the least important of the three factors. So the next trend you need to know about is melting and boiling point trends. And the trend in this is that the melting and boiling points increase as you go down the group, which we could see from our first slide because we said there were gases at the start. Fluorine and chlorine are gases, then bromine's a liquid, and then iodine's a solid. So the melting and boiling points have increased as you go down the group. And the explanation for this is that larger atoms have got more electrons. So we've already said that as you go down the group, the atomic radii increases. Those larger atoms have got more electrons. And as you know, the van der Waals forces, the strength of the van der Waals forces depends on how many electrons there are. So the more electrons you've got, the stronger the van der Waals forces are going to be. The van der Waals forces between the molecules are stronger. And of course, stronger forces, if you've got stronger forces between the molecules, then they need more energy to overcome them. A brief word about wording here. Although we're talking about the atoms having more electrons, when you're talking about the van der Waals forces, it's between molecules. You've got to remember that the halogens are diatomic. So they all come as F2, Cl2, I2, and Br2. So they're diatomic. So when you're talking about the melting and boiling points, you're not breaking covalent bonds. You're overcoming the van der Waals forces between the molecules. So back to our lesson objectives. which were to describe the trends in atomic radii, electronegativity and boiling points for halogens, and then explain those same trends. So hopefully you can do that by now. If not, then rewatch the video, look at your textbook, do whatever you have to do to make sure that you completely understand these points before you come to lesson.